Okay, so the first limit that I want to look at is the limit as x goes to 4 of 1 over x minus 4 squared. And I am going to show you a table and a graph, but here's what I'm going to tell you. After we do our first one, they are pretty easy to spot graphically. So whereas before, like on a graph, if it was approaching a fixed number, then that was a lot harder to see. So I would say we're going to shift mostly towards graphing, and then if I have time, I'll talk about how in calculus we don't have graphs or tables, so we got to kind of think about what kinds of numbers they are. Okay, so can we see here that if I would put 4 in, that would make me divide by a 0? Okay, so sometimes we can remove it and there's a hole in the graph. This case, we can't, and so what that means is there's going to be an asymptote in the graph. So either the function is going to approach like negative infinity and positive infinity, and so therefore there's no limit, but sometimes it approaches both infinity or negative infinity for both sides. So that's kind of what we have to decide. So we're going to do our table, and we're going to still put 4 in the middle, just like before. Okay, so we got our x. So then we're going to do 4.001, 4.01, 4.1. That's our zooming in around 4. And then on this side, 3.999, 3.99, and 3.9. Okay. Let's get our calculators out. We're going to make sure we use parentheses. Go to my table function, like I taught you yesterday to set it up. So okay. That's what that means. 1 times 10 to the 6. That's really large, right? Okay, are we seeing something here? From this side, these numbers are getting really, really, really big, right? And so we would call that positive infinity. From this side, they are also getting really, really big in a positive way. So positive infinity. And let's look at the graph so you can kind of see the graph too. Do you see from the left and the right, if I came in around 4, they're both going way, way up. Okay, now technically in calculus terms, infinity is not a number, right? Infinity is not a real number. It's a kind of a concept. And so technically, when we get to calculus, we'll say the limit doesn't exist, but the limit would approach infinity. But for our purposes today, as long as it's approaching the same thing, we're going to write, hey, the limit of this is just going to be infinity. Okay, I wanted to show you what a table looked like. Let's throw a couple more up there. And how about the limit as x goes to 0 of 1 over x? So now let's just kind of look at this one. I don't know how much analysis we have to do except just to realize that this is a little bit different. Why? There we go. Why is this one different? From the left, this is going to negative infinity. From the right, this is going to positive infinity. Okay, do you see the difference between that one and the last one? Okay, so when we have limits involving infinity and from the left and the right, they're approaching positive and negative, we would say the limit doesn't exist. Do you need me to talk about that more? Okay, so a limit means that from the left and the right, the function must approach the same value. From the left, this approaches negative infinity, and from the right, this approaches positive infinity. That is not the same value, and so the limit does not exist. Yes?
Are you always looking like towards 0?
No.
To figure out what they're approaching?
No, this set tells me where to look. This is saying look as x approaches 0. This one we looked as x approached 4. So I will tell you what to approach using that notation. Okay? If we were doing a table, I can do that a second. So you can kind of see. Do you see these are getting bigger, but they're getting bigger in a negative way? But then these are getting bigger in a positive way. So approaching two different values. Okay, let me show you another way. This one's kind of cool. Are you ready? This one I'm going to do as x approaches 0 again. Would you graph x, or sorry, cosine of 1 over x a minute? Oh, we got to change our mode. I have to change my mode. Make sure it's in radians. Weird. Did you see that same little blippy thing? Okay. Here's what we're going to do. Are we ready? Did you get this picture?
Yeah.
I'm going to go to the middle. So we're going to trace, and at 0 it definitely doesn't exist because you'd be doing 1 divided by 0. I can't get rid of it. What we're going to do is you're going to do the zoom function, and we're going to do zoom in and hit enter. Whoa.
What does that mean?
I don't know. Let's investigate. Let's do zoom in again. What in the world is going on there? Did you see the graph go like this? Okay, zoom in again. Do you think you're going to be able to find that limit? No, we call this oscillating behavior. What's happening is the graph is oscillating. Remember when we involve cosine and sine, that tends to happen? It oscillates, but then as it gets closer to 0, it starts going crazy, back and forth. And there's no way to evaluate that limit because as we zoom in, the oscillation is going to just increase. And we don't know which side is it going to. It does not approach a fixed value, but it's for a different reason, okay? So this one doesn't exist. We call that oscillating behavior. You might see some of that today. Okay. Let's shift gears and do limits as x approaches infinity or negative infinity. Okay, so these are all x approaching some value where there's some kind of asymptote or undefined value. The other way we can look at limits is as x gets really big, what is the function approach? And we have talked about this before. I don't know if you remember this. Okay, similar question to the one I asked before, but the one I asked before, I asked what was the limit as x got closer to 0, right? This is asking what happens as x gets really big. Okay, when we get to calculus, this is one of the ones we memorize. Generally with numbers, what happens if you put a really big number on the bottom of a fraction? It gets smaller and smaller and smaller and smaller. It gets closer to what number? 0. Okay, if you start holding a 1 on the top and I blow up the bottom, okay, that whole thing's going to go towards 0. So without even looking, I already know numerically, if I put a really large number and I keep getting larger and larger and larger, this is going to have a limit of 0. But let's look at what goes on graphically. Let's go back. We're going to make this 1 over x, and I'm going to go back to a standard viewing window. So zoom 6. Okay, we saw this before, right? What I'm talking about is if I were tracing and I just traced, okay, you see my cursor right there? And I just keep going, holding it on that cursor. Right now I'm making x approach infinity. It's going to go off the screen in a little, but my screen moves. Do you see this number's getting smaller and smaller and smaller and smaller? We call that end behavior because it's at the ends of the function, but it approaches 0. And generally, no matter what, if the power on the bottom is bigger than the power on the top, that's what happens. Okay, the whole thing is going to be approaching 0. Okay, that makes sense. Let's take a look at something like this then. What if I asked for the limit as x goes to negative infinity of negative 3 over x squared plus 2? And we are going to look at this graphically again, but especially because some of you are taking calculus, I want to talk about this one. All right. So, quick question here. That negative infinity just means a really large negative number. When I put that into this function for x and I square it, what happens to this whole thing? It gets really, really small. It drives that whole, right? Same concept as before. Does the negative and positive in this case really matter? No, because it's approaching 0, and it is actually approaching 0 from underneath. But that doesn't matter, it's still approaching 0, okay? So this part is approaching 0. Does x affect this part? No, because there's no x there. Anyone want to take a guess to what the limit of this whole thing is then? Positive 2, because if this is approaching 0 and this remains fixed at 2, okay, let's take a look at the graph. So there's my negative 3 over x squared, and then there's my plus 2. I'm going to go back to standard viewing again. Okay, do you see that horizontal line at 2? And as x goes, this time I wanted to go to negative infinity. If I traced, here we go. I'm making it really large, and this is going to get closer and closer and closer and closer and closer to 2. Okay. All right, so for limits involving infinity today, can you do a table? Yeah, but because they're going to involve numbers like 0 or fixed numbers, I would just look at the graphs today for that part.